Volunteers began removing the brake stand and other cab items, so a new floor can be fabricated to allow access for the Stoker vertical feed section as 2100 is returned to a coal burner. Continued removal of the tender brackets that are no longer needed. Volunteers freed up and cleaned corroded Stoker auger U-joints. And work continued on the Stoker trough auger.
I headed up to Mentor, Ohio to Blyle Machine Company. They're our specialty contractor to start the machining and forging process on our flexible and rigid stay bolts. Why don't you come along with me and I'll show you a little bit more about how the process works. So the first stage here in making our stay bolts is to use this cut-off saw. We set a stop and we'll cut all the stay bolts of each length in a production fashion. And of course, anytime you're doing any kind of production work, you want to keep an eye on your quality control, so we're always measuring to make sure that the stop hasn't moved. And then once we cut our test pieces, then we carried them down to the building in the back where the actual forging process would take place. So before forging the stay bolt, the piece of 1-inch stock has to be heated up to a almost molten state so that it can be shaped or formed in the upsetter. In this case, we're using an electric induction furnace that uses this coil that, as you can see, within about 15 seconds time will take the steel to a nice glowing orange state. Now here Chan has set the piece in the upsetter. The two pieces that actually hold the shank of the stay bolt are called the gripping dies, and then the actual hammering is done by the forging head itself. And here's what they look like when they come out. And here we're already making steam with our new stay bolts. So the next step is that we at that point have a rough forged spherical head. The key here is that we need to get a nice machine surface. So with a single form tool that's been ground out of high-speed steel, we'll be able to machine each of these heads to get a nice consistent round shape. Despite only 2 work sessions in the month of February, we have still been very productive. Work continued on removing items from both above and below 2100's cab floor in preparation for its removal and ultimate replacement with new steel. Since we are returning the locomotive to burning coal, a new floor will be fabricated that will allow space for the Stoker feed mechanism and grate shaker bars. The Stoker feed screw continued to receive attention as the blade fins were built up with new weld material, then ground back to a good finish profile to renew the auger screw. Additional brackets in the tender have been removed so the Stoker feed trough can eventually be reinstalled in the coal bunker.
One of the projects we continued on was the removal of reflective tape on the running board skirting. With heat guns and lots of elbow grease, the red tape was removed. Once all the tape is removed, the areas will be cleaned of the adhesive and be ready for priming and painting. The steel floor was removed from the cab. A new one will be made to replace it with areas cut out that will allow space for the grate shaker fingers and the Stoker auger housing. Speaking of the Stoker, the U-joint pin and joining parts of the auger were ground out. Angle brackets that once held the oil tank and the tender in place are being repurposed to make steps up the slope sheet inside the coal bunker of the tender. Thank you for your support. One of the very exciting things that has started in the middle of May is forging and machining of the 540 stay bolts has begun. As shown in the February update video, the bolts are cut to length from bar stock. Once they are cut to length, the stay bolts are cleaned on a grinder to remove any burrs. The new stay bolt is put into the lathe to drill the telltale holes. The drilling of these holes are a very important safety feature that will alert us if a stay bolt is broken inside the firebox with the water and steam coming out of it. Volunteers use great care when drilling to not break the bit, which helps cost and production times with our budget.
In the past month, our volunteers have remained very busy with various projects on Reading 2100. First, the 3M reflective tape that once was on the running board skirting of the engine has now been completely removed. Work has begun to remove the glue residue so primer paint can now be applied and the engine return to its as-built appearance. An inventory of spare parts was taken out of the storage area inside of the auxiliary water tender.
This is my favorite activity.
The grease cellars and components for 2100 were cleaned of all oily gunk, grime, and dirt. The steel apron that sits between the locomotive and tender was cleaned and painted. A water pipe from the tender to the engine that had suffered freeze damage is now being prepared to be fixed by brazing. The biggest thing to happen in the past month was when several American Steam Railroad board members visited the Reading and Northern Railroad restoration shop last week. We were allowed to visit their shop and inspect the restoration on sister engine number 2102. Much to our delight, when we first got there, the steam crew presented us with a fire door casting, which will help us in our progress to convert the 2100 back to coal. We'd like to extend a big thank you to Andy Moeller and the team at the Reading and Northern for this donation, along with allowing us to spend almost an entire day answering our questions about 2102's rebuild and giving us a lot of great advice. Thanks to your generous outpouring of support, the forging and machining of the 560 stay-bolts is fully funded. Currently, volunteers are drilling out the telltale holes with aircraft-grade drilling bits, first to a 9-inch depth, then to a 12-inch depth. After the round head of the stay-bolt is forged, the final drilling will go 1/3 of the way into the spherical head. To date, over 300 stay-bolts have their telltale holes drilled to a 12-inch depth, with 50 having their heads formed. One of the first items we worked on was the removal of damaged studs on the feedwater line on the fireman's side of the tender. We tack welded the nuts, then used a little heat persuasion and a lot of elbow grease to break free those stubborn studs. The steam distribution manifold from the stoker mechanism was removed from its housing. The piece is currently sent off to a contractor who will rebuild it to a like-new condition. A complete inventory of spare parts was completed in the auxiliary water tender. Rear steps were also found in the auxiliary tender for the main tender, and they were remounted. Our tool car, former New York Central baggage car number 9110, received attention from our crew at the Mad River and Nickel Plate Railroad Museum's new restoration shop in Bellevue, Ohio. While we were there, volunteers cut into the car to remove the old fiberglass insulation and to better assess the car's condition to see what will be needed to be done in the restoration process. After our work session, Mad River Vice President Dwayne Furian instructed us on how to perform a clean oil test and stencil on the car. He gave us a complete lesson on what's needed to be done on 9110 before it tags along with us on excursions. We'd like to thank the Youngstown Steel Heritage Foundation for their donation of D22 brake components to the 9110. Projects done in the past month include removing various items out of long-term storage, including tender doors, grate shaker bars and mounts, along with other items. Volunteers squeezed under the engine as well to reapply grease to the main axle areas. They also applied a light oil to grease cellar parts to prevent rusting. The feedwater pipe from the tender that suffered cracks from freeze damage has now been repaired by brazing. It was found in the tender that one of the shut-off water valves to the engine had a bent rod. This was taken out and parts around the area were cleaned, so a new filter screen and rod can be put back into place. Volunteers also explored the inside of the tender where 19,000 gallons of water usually would be. We found that the baffles and floor to be in good shape, and that this area will need to be cleaned during a future work session.
Work in the past month of September was focused on the firebox, where 560 stay bolts are to be welded in. The firebox side sheets and stay bolt sleeves were cleaned of dirt and other grime, so when the welders come in the next week or two, a good surface is prepared for them to work on. Likewise, the stay bolts were taken from Beal Machine in Mentor, Ohio, and transported to the Midwest Railroad Preservation Roundhouse, where the restoration of Reading 2100 is taking place. The stay bolts were prepared for welding by being checked for quality, sorted by length, and sandblasted, where they will be welded in with the round end resting in a sleeve. The copper gaskets that will fit in the caps over the stay bolts arrived ready to be installed. We'd like to say thank you to Doyle McCormick for getting us in touch with one of the vendors to help complete this project. Other work done included a visit from a steam contractor who helped us with the alignment and inspection of the driving boxes by taking many measurements. His calculations help us determine how much wear is on the wedges, axles, driving boxes, and wheels. He also inspected the side rods for wear. His findings have so far determined a savings of a considerable amount of anticipated work.
Throughout the month of October, we've been busy preparing the stay bolts for welding. The main task being media blasting with a grade of 4070 crushed glass that auto body shops use, which removes the mill scale on the bolt surface without etching into the steel. This will ensure that the welders have a pure metal surface to weld to. The casting for the stoker's jet distribution table inside the firebox was found to have some damage, which will be repaired by Gemini Industrial Machine Group of New Philadelphia, Ohio. And now Brian Smith presents this month's Technology Corner segment. Brian, on to you.
Thank you, Forrest. What I have here is an ultrasound testing device. This is a device that uses acoustic sound waves to detect the thickness of materials, such as a boiler shell right here. Now, the reason why we're doing this is that the locomotive's 1472-day inspection is coming due next summer, and a full boiler survey is required for the next inspection. What we have to do is grid off the boiler into 8-inch squares, clean up 3 spots to take readings, then record those readings to a document so both the FRA and we know the thickness of the boiler. We then compare our readings to a calculated thickness to be sure we have a 4-times safety factor over the entire boiler. Now, taking readings is pretty straightforward. First, you apply some petroleum jelly, much as your doctor would do when they're doing an ultrasound. So I'll put a little bit right here. Now, we got to make sure that when we put the probe on there that it makes good firm contact. So we get a good reading there. And as you can see right there, we got a reading right there. We survey the entire boiler, but we pay special attention to areas where water could have collected while the engine was in storage. These areas tend to be the most likely spots to find corrosion.